Welcome to this class. So this class is a revision session to revise on questions that has to do with trigonometry and further differentiation. Okay, so I've got the questions from last year's test one. Okay, so I just picked out questions that has to do with trigonometry and further differentiation from this paper here, the test paper, the test one for last semester. Okay. So that's what we're going to discuss in this video. But for those who are interested in accessing the videos to all these other questions as you prepare for your actual test one and not the quiz, okay? Please feel free to register with us and you find the videos on our website. Okay, so now let's revise some questions on trigonometry and further differentiation. Okay, so the first question here is saying determine the dy dx at the point 2, 3 given the following equation. So this is the equation that we've been given here. So here we have to understand or identify the type of equation that we've been given. Okay, so there are two types of equation that you can be given. You can be given an explicit function, meaning y uh, will be defined entirely in terms of x. So simply meaning y will be the subject of a formula, and then you have a function of x like that. So for you to find dy dx, you just differentiate. It will be easy. Okay. And then another type of function that you can have is what they call the implicit functions. Okay. So these implicit functions, this is a function where okay, y is not entirely defined in terms of x, okay? There is no proper distinction, or in short, you cannot separate the y from the x in the given equation. So this is the case here. We can't separate these two, okay? We can't make y the subject of a formula here, or making x the subject of a formula here. It won't work. So in that case, when you have an implicit function, okay, you use implicit differentiation. Okay, so that just cause that we'll be treating whenever we can see y, we'll be treating it as a function of x. So we'll be adding an extra dy dx or a derivative. So what we're going to do here to find the dy dx at this point is first of all find the dy dx, of course, and then later on evaluate it at 2, 3. So we're going to say I'm finding the dy dx, okay, of this function here. So I'll write 2 to the power x plus 5 sine y is equals to 4/3 and then x y squared. So this is what we have. Okay, so I'm going to apply this dy dx to each and every term there. Okay, so what's the derivative of an exponential function? Okay, so if I have an exponential function, maybe a to the power a function of x, then its derivative is, okay, I first differentiate the power. So I find the derivative of the power, okay, and then I multiply by ln of the base that I have there, which is just a. And then I multiply by the same function like this, okay? So this is the rule that we apply when we are differentiating an exponential function. That's why when I have e to the power x, okay, it will turn out to be the derivative of x, which is 1, multiplied by, and then I say ln of the base that I can see. So this will be ln e, and then multiply by the function itself, e to the power x. No wonder I say the derivative of e to the power x is the same as e to the power x, because this is 1, and then ln base e, ln e here is also 1. So we're just multiplying 1 and 1, and then we get this. So that's what we are going to apply on this function here, because that power is just a function of what? X on the 2. So it means the derivative of this guy will just be, what's the derivative of this x? It's 1 multiplied by ln, and then I put the base, which is 2, and then multiplied by the function itself. So this is what I have. Okay, I say plus, what's the dy dx of this? Okay, so now notice that here we have y there. Okay, so when I'm finding y, I'm going to be treating this, when I'm finding the dy dx, I'm going to be treating this y as a function of x. So apart from this derivative that I'm applying, I'm going to add an extra dy dx for this y that I can see there. Okay, so what's the derivative of a sine? Okay, so the derivative of a sine is cos y, Okay, but since there's y here, okay, I'm also finding the derivative of this y with respect to x. So I'll add an extra dy dx because there's y there. Okay, so wherever there's y, we're going to be adding an extra dy dx. Then I'm going to say this is equals to, okay, so 4 over 3, I'll put it outside the brackets, and then I'll apply the dy dx to the xy squared. So here we have a product. So we apply the product rule, right? Okay, so it means I'll differentiate this one, and then I'll keep this a constant, and then I'll come and differentiate this one, and then I'll keep this a constant. Okay, so let's start. If I differentiate x, I'm going to get 1 multiplied by this one, I keep it a constant. And then I say plus, okay? This x, I keep it a constant, and then I differentiate this one now. So if I differentiate this one, this is y. So I'll need to add an extra dy dx. So what I get is what? What's the derivative of y squared? It will just be 2y. And then since it's y, I'll add an extra dy dx. Okay, so that's how it works. Okay, and then from here, we're just trying to put like terms together. Okay, those who have dy dx, we put them together and then we make it the subject. So this one here gives me ln 2 multiplied by 2 to the power x, okay, plus 5 cos y dy dx is equals to, here I can multiply throughout by these things here. So 4 over 3 multiplied by y squared, I get 4 over 3 y squared, and then plus 4 over 3 multiplied by this. Okay, I get 8xy divided by 3, and then dy dx. Okay, so that's what I get there. And then let's take like terms together. So these ones here that have dy dx, let's put them on the same side. Okay, let's put them on the same side. So I'm going to say 5 cos y dy dx. And then this part here that has the dy dx comes here. So it will be minus 8xy over 3 and then dy dx. Okay. And then is equals to, this one has remained here, 4 over 3y squared. And then this one here has gone to the other side. So it's minus ln 2 and then 2 to the power x. Okay, so that's what we have. Okay, so now on the left side here, we're going to factorize the dy dx. Okay, so what do we remain with? We remain with 5 cos y minus 8xy over 3. Okay. And then on the other side, we just have 4 over 3 y squared minus ln 2, and then 2 to the power x. So yeah, so it's ln 2 and then multiply by 2 to the power x. Okay, so now here we can find our dy dx, right? So we're going to divide both sides by 5 cos y minus 8y x to the power 3. I mean divided by 3. So this will be dy dx is equals to 4 over 3 y squared minus ln 2 and then 2 to the power x divided by 5 cos y minus 8xy over 3. So we found our dy dx. Now let's evaluate it at the point that we were given. Okay, so if you have any questions, please feel free to ask. Okay, just unmute yourself and ask. So we are evaluating it at what? At 2, 3. So wherever there's x, we are putting 2. Wherever there's y, we are putting 3. So this will be equals to 4 over 3. And then where there's y, I'm putting 3 squared minus ln 2 multiplied by 2 to the power 2. Where there's x, I'm putting 2. Divided by, what are we going to have down there? We're going to have 5 cos 3, okay, minus 8 over 3. And then x is 2, y is 6, is 3, I mean. Okay, I went a step further in my mind. Okay, so that's what we have. So we just have to simplify this now. So this is equals to, here I have 3 down and 3 squared. So I can cancel one of these 3's and this one. So just remain with 4 multiplied by 3. So I get 12 minus here. Okay, here, this one here becomes 4. So I can put it in front. So I write 4 ln 2 like this, divided by, down here, there's nothing that we can do to the 5 cos 3. Just leave it the way it is. And then here, I can see 3 and 3 there. So I can cancel out the 3, cancel out the 3. So it will be minus 8 multiplied by 2. That will give me a minus 16. Okay. And this will be our dy dx evaluated at 2, comma 3. Okay. So any questions there that you have on this question? Okay, so if there are no questions, I'll proceed to the next one. So the next one is on trigonometry. Okay, it's on trigonometry, and it's a very simple question. They're just saying in medical imaging, okay, certain signals can be modeled using trigonometric wave functions. So suppose the signal is represented by the equation, this equation that they've given us there, okay? Express this equation in the form r sine and then 2x uh, plus this symbol here, okay, which just represents an angle. Okay, so how can we represent this guy, okay, into this guy? So we need to find two things. We need to find the value of r, and then we have to find the value of this angle here. Okay, so how are we going to do that? Okay, how are we going to do that? We're going to take advantage of double integrals. Double angle formula. Okay, so remember, if I have sine A plus B, this will be equals to sine A cos B plus sine B cos A. Remember, right? So we're going to use this to expand this. Okay, and then we equate it to this guy. So I'm going to say r sine 2x plus angle is equals to, okay, so now let's expand this here using this double angle. So it means of course, the r is outside there. So it means here I have sine 2x, okay, cos angle, and then plus sine angle cos 2x. Okay, so this is what I have by the double angle formula, right? Okay, that is what I have. And then from here, we can multiply throughout by r. So this will be r sine 2x cos angle plus, okay, so this is simply alpha. And then here to be sine alpha cos 2x. Okay, so this guy here, I've expanded it and it's now equal to this. So I'll get this expression here, okay, and equate it to what we've been given there in the equation. Okay, so it means what we're going to have is the following. Okay, what we're going to have is the following. So we're going to say r. Okay, so here I forgot to multiply the r, right? Because this r was outside the bracket, so it multiplies here and it also multiplies there. So here I should put the r like that. Okay, and then now we can equate. Okay, so here we're going to say r sine 2x cos theta, cos alpha plus r sine alpha cos 2x is equals to, and then we equate to this. So this will be 3 sine 2x plus 5 cos 2x. Okay, so what do we see? We can see some similarities here. We see that this expression here is sine 2x. Even this one has sine 2x. So I'm going to equate this to this. This one has cos 2x. That one has cos 2x. So I'm going to equate this with this. So let's equate. So the first one is r sine 2x cos alpha is equals to 3 sine
Uh, excuse
2x.
me.
Yes?
Yes, I think I'm behind. I'm on the where we after we multiplied r by sine 2x cos theta plus sine theta cos 2x.
You are aware? Can you repeat again?
Uh, I meant by the point just after we multiplied r with the sine 2x cos theta plus sine theta cos 2x. How did
Uh-huh.
we get these? Mm.
Okay,
Okay, so
so
I got that part, but that's where I lost it.
let me just go back a bit. Okay, so we were here, right? We said this was the expansion for this. When we expanded this, we got this. So we are together here, right?
Yes, yes,
Uh-huh. So now we are saying, let's equate this thing here that I've put in the box to what we've been given here in the question, this one here. So that's what I did. So I just got this part in the box, and then I equated it to this part, which is this. You've seen it?
yes.
Uh-huh. And then now I'm saying we can notice some similarities here. We notice that this term here has a sine 2x. And then when I go to the other side here, to the right-hand side, this term also has a sine 2x. So I can equate this one with this one, and then I can equate this one here that has cos 2x with the one that has cos 2x. So that's the part where I was now.
Oh, okay. Okay, thank you.
All right. So now let's equate these two things. So this one, I'm equating it with this one. So we are saying r sine 2x cos theta should be equals to this one, 3 sine 2x. And then this one, r sine alpha cos x should be equals to 5 cos 2x. Okay, and then what do we see here? I can see that I can divide by sine 2x here. Even here, I divide by sine 2x. Okay, so the sine 2x, sine 2x, sine 2x, sine 2x goes. So what we remain with is just r cos alpha is equals to 3. Okay, and then even this side, we can do the same. So it will be cos 2x here. Okay, even there, cos 2x. So the cos 2x, they cancel. So I remain with r sine alpha is equals to what? To 5. So now we can use these two equations, this one here and this one, to find one, the value of r, and then two, to find this angle here, alpha. Okay, because you can see the angle alpha, even there, the angle alpha. So what am I going to do? Okay, so let's start with the angle. Okay, so how can we find the angle? So the angle, we're just going to use the tan identity. So we know that tan, okay, of an angle theta is just equals to sine theta over cos theta. So I'm going to take advantage of this. I'm going to divide r sine alpha is equals to 5 divided by r cos alpha, and then is equals to 3. So we see that the r and the r, they go. This sine alpha cos alpha, they will make a tan alpha. Okay, and then this is equals to 5 over 3. So we can use this now to find the angle. So we're going to multiply both sides by the tan inverse. So if I multiply by the tan inverse here, I just get alpha is equals to the tan inverse of 5 over 3. Okay, so make sure you put your calculators in radians. Okay, because here the angle they're saying this alpha is between 0 and pi over 2. So this is radians. So put your calculator in radians and then punch this one here. So the inverse of tan 5 over 3, according to my calculator, so please confirm it, I'm getting 1.030. Okay, so I found my angle, my alpha. My alpha is just 1.030 rad. Okay, so now that we found our alpha, which is this, we're just remaining with the r to express this guy in this form. So now how do we find the r? Okay, so we're going to do a very nice trick. Okay, we're just going to do the very nice trick that will involve this identity here. So remember, sine squared theta plus cos squared theta is always equals to 1, right? So we're going to use this. So what am I going to do? Okay, what am I going to do? I'm going to, first of all, add these two. Okay, so I add whatever is on the left. So it will be r cos theta. Okay, uh, if I add it with okay, with this one here plus r sine theta is equals to, so this one here, the first part is equals to 3, and then plus the second part here is equals to 5. Okay, so now I'm going to take advantage of this property here. So what am I going to do? I'm going to square all these things. So this one, I'll square it. This one, I'll square it. This one, I'll square it. Even this one, I'll square it. So since I've squared everything, then I'm not changing anything. Okay, so this one gives me r squared cos squared alpha plus here to be r squared sine squared alpha is equals to 3 squared, which is 9, plus 5 squared, which is 25. So we see now that the r squared is common between these two. So I'll say r squared, and then in the brackets, you see that I get this identity. So it will be cos squared alpha plus sine squared alpha is equals to 9 plus 5 is 34. Okay, but this what we have inside here, it's the same as this. So which is just what? 1. So it means my r squared will be equals to 34 or 34. And then to find the value of r, I take the square root of both sides. So r will just be equals to the square root of what? 34. Okay, so if you have any questions, please ask. So we found the value of r to be the root of 34. And then we found this angle here, the alpha, to be this. So we can actually represent this in this form. Okay, so let's write it. So it means in that form, r sine 2x plus alpha, this will just be equals to the root of 34 sine, okay, 2x plus, why am I writing alpha? Okay, so sine 2x plus this angle here, which is 1.030. So I've successfully expressed this guy in this form here. So any questions there? Okay, because the next question we are going to use this same result here. Okay, if no question, we proceed, but we are still using this result. So the other question here, you can see they're saying solve for x is between 0 and pi for the equation, this equation here. But this equation here is the same as this equation here. Okay, it's the same. We can see this one, it's the same as this one. Okay, this part here. This part here. It's the same as that part here. So we know that this one can be expressed in the form what we determined there previously. We said it is the same as 34 sine 2x plus 1.030. Okay, so now this here is the same as this part here. Okay, and then it's equals to 4. So now we can solve for x. Okay, so the first step we're going to say this is sine 2x plus 1.030 is equals to, so I divide both sides by the root of 34. So this is 4 over the root of 34. So we need calculators there. Okay, so from here, I'm going to um multiply throughout by the inverse of sine. So if I multiply the inverse of sine here, the sign goes. So I just remain with 2x plus 1.030. Okay, and then this will be equals to this sine inverse of 4 over root of 34. So you just have to punch this onto your calculator. Okay, so what do we see here? What will be the value that we're going to get? So our 2x plus 1.030 will be equals to, so if I punch this on my calculator, okay, it's giving me 0.686. Okay, but now we are getting two answers. Okay, so this one will lead to one answer. So we need to find another number that will lead to another answer. So remember our quadrants. So all students take Coke. So here all the three trigonometric ratios are positive. Here only the sine, here only the tan, here only the cos. Okay. And then if you find an angle in the first quadrant, you just get it the way it is. Okay. And then here, to find the angle here, we're going to be doing 180 minus theta. Here we're going to be doing 180 plus theta. Here we're going to be doing 360 minus theta. Okay? But now here we're dealing with radians. So we change everything to radians. So here you just get the same theta. Here, 180 is the same as pi minus theta. And then here it will be pi plus theta. Here it will be 2 pi minus theta. Okay? That's how we're going to get the answers. So here, this value is positive. So meaning the sign is positive. Okay? So it can only be in the first quadrant and the second quadrant. Okay? So this is the first value here. We can take this value as the value for the first quadrant. So we need to find another one for the second quadrant. So how do we find that? We use this equation. So we're going to say this same thing here, okay, can also be equals to another angle, which will be in the what? In the second quadrant. Okay, so this angle will be pi minus 0 point what now? Okay, 0 point, okay, did I get the correct answer here? Let me punch it again. Let me punch this one again, this part here. Okay, so sine inverse of 4 over root of 34. Okay, so it actually gives me another value, not this one that I wrote. So the value that I get is the correct value, okay, is 0.758. So you try it, okay, to confirm. So sine inverse of this, it's giving me this, okay? And then so the other angle now will be pi minus this, so 0.758. Okay, and then from there we can find our two values for the x, because remember here they're saying write your final solutions to two decimal places. And then from 0 to pi, we're going to get two solutions. Okay, so let's get the first solutions first of all. So we're using this one down here. So it will be 2x is equals to pi, okay, minus 0 point. Okay, so you're saying you're getting another value. Okay, you're getting 0.756. Okay, it's closer. So it's just the difference of the calculator that we are using, but it's closer to this, so it's fine. Okay, so here it will be, if I get this equation down here, to be 2x is equals to pi minus 758, and then minus this one, I've taken it to the other side. Okay, so my 2x here will be equals to, okay, my 2x there will be equals to what? Okay, it will be equals to 1.354. Okay, and then from there, I just divide this by 2. So divided by 2, x will be equals to, if I divide this, I'm getting 0.677. So this is the first value of x that I get from this equation down here. So I'm going to write it there. Okay, and then now let's use this one here on top to see the value of x that we are going to get. So the one on top, we have 2x is equals to 0.758 minus 1.030. So 2x will be equals to this one minus this. It gives me a minus 0.272. Okay, so meaning here, what would be my x? Okay, meaning here, what would be my x? So my x would be what now? Okay, my x would be what? Okay, or maybe before you even find the x, we notice here that we get a negative value. So it means when I divide by 2 on both sides, I'm going to get x, which is negative. But that's contrary to what they said the range of x should be. They said x there should be what? Should be greater than 0. This means x is greater than 0, but it should be less than pi. So what are we going to do? So whenever you have a situation where you have a negative number here, okay, you always introduce 360 or 2 pi. So if, for example, I have a negative angle, okay, for example, if I have pi is equals to minus 30 degrees. To turn this negative angle into a positive angle, I'm just going to say this pi as a positive value, it's equals to, I introduce 360 in front, and then I say minus 30 degrees. So this would be 300 degrees. So 300 degrees and minus 30, they are the same angles. This one is just in the negative form. This is a positive one. So even this one here, it's negative, right? Okay, so meaning I'm going to introduce 360 in front here. Okay, but here I'm dealing with radians. So my 360 is the same as 2 pi. So this one will be 2x is equals to, I'm trying to change this negative angle to a positive angle, like just like I did here. So it will be 2 pi minus this. Okay, and then from there, what do we get? We get a positive value here. So 2 pi minus 0 0.272, okay? I'm getting 2.87. Then I divide both sides by 2, even this side by 2. I get x will be equals to, as a positive value, 1.43. Okay, so we have two values for x. The first one was this one here, which is 0.677. And then the second one is x is equals to this one that I've been finding. From the negative angle, I find the positive angle, which is 1.43. So our values of x are these ones here. And you can see that these ones, the x is indeed, okay, between pi and 0. Okay, so any questions there? Okay, so let's look at the next one. Okay, I think this is the last one for today. So this one here, they ask to solve a trigonometric function. Okay, but we have to make use of a certain identity. Okay, so it's very important for you to know identities when you're solving trigonometric functions. So here I can see I have cot squared x minus cosec x minus 11 is equals to 0. So if you don't know the identities here, there's nothing that you can do. Okay, you will just fail the questions. So always know the identities. I'm sure when you're writing your exam, they even give you a leaf for the identities, right? Okay, so here the identity that we're going to use is this one. Okay, we're going to use the identity. We're going to use the identity cosec squared x minus cot squared x is the same as 1. Okay, so this is the identity that you should know. Apart from the cos squared theta plus sin squared theta is equals to 1, even cosec squared angle, which can be x or it can be theta, minus cot squared x is actually equals to 1. Okay, so a very useful identity. So it means here I can turn this cot into a cosec. So if I make the cot the subject of a formula, cot x will just be equals to, okay, if I take this on that side, so this will just be cosec squared x minus 1. So here I'm going to put this. So I'm going to say cosec squared x minus 1, and then minus cosec x minus 11 is equals to 0. So this will be cosec x squared minus cosec x minus 12 is actually equals to 0. And then from here, we can say let y be equals to cosec x. Okay, let y be equals to cosec x. So it means here I'm just going to put y squared minus y minus 12 is equals to 0. So we have a quadratic equation. Okay, so just solve a normal way we can solve. So here, the factors are just minus 4 and positive 3. Okay, so it will be y squared minus 4x plus 3y minus 12 is equals to 0. So I can group this, I can also group this. So I get y minus 4. And then here, I get plus 3 y minus 4 as well. It's equals to 0. So my equation is just y minus 4, and then y plus 3 is equals to 0. So I get y is equals to 4. And then here, I get y is equals to minus 3. Okay, but y is equals to this. And we're interested in finding the values of what? Y. So we're going to get this one. It's going to give us two solutions. Even this one is going to give us two solutions. So if I get my y as 4, then I have cosec x is equals to 4. Okay, but cosec is just 1 over sine. So I have 1 over sine x is equals to 4. So this simply means sine x is equals to 1 over 4. Okay, so how did I do that? This is 1 over sine x. This is 4 over 1. So I move the 1 on top, even the sine x on top, and then whatever is down, I move it. Whatever is on top, I move it down. Even there, I move it down. If you want, you can cross multiply, and then you make sine x the substitute formula. You still get this. So this is the first equation that I have. The other equation will be um, cosec x is equals to minus 3. So meaning 1 over sine x is actually equals to minus 3. So this one gives sine x is equals to minus 1 over 3. So here, okay, my sign is positive. So meaning I can find it in the first quadrant and the second quadrant. Here it's negative. So meaning I can find that angle in the third and the fourth quadrants. So what am I going to do? I'm going to say x is equals to sine inverse of 1 over 4. Okay, so here just punch on your calculator. So notice that the angles here are in degrees. So make sure your calculator is in degrees there. Don't forget. So this gives me approximately 14.48 degrees. Okay, so this will be the angle in the first quadrant. So in the second quadrant, we said it's just 180 minus the angle in the first quadrant. So it means my other x will just be 180 minus 14.48. So this here is going to give me 165.52 degrees. Okay, so I have this one and that one. Okay, let's also find here. But here, notice that the sign is negative. So we'll be considering angles from the third quadrant and the fourth quadrant. So here, x will be equals to sine inverse. Okay, for now, we can ignore the negative. So punch this onto the calculator. We see what we're going to get. Okay, I get 19.47%. So degrees, I mean. So this angle here, it's in the first quadrant. Okay, it's somewhere here. But since this was negative, we are only interested in the angle that will be here and there. So here we say it's 180 plus the angle in the first quadrant. Here it's 360 minus the angle in the first quadrant. So it means my x in the third quadrant will be 180 plus 19.47. So this is giving me 199.47 degrees. My other x will be in the fourth quadrant. So that will be 360 minus 19.47, which gives me a 340.53 degrees. Okay, so our answers are 4. The first one, the second one, the fourth one, the third one, and then the fourth one. So you may want to write them in increasing order. So what we're going to do is this. We're going to say x is actually equals to, okay? So in increasing order, I start with 14.48 degrees. And then what follows is 165.52 degrees. And then I have 199.47 degrees. And then I have 340.53 degrees. So this is what we have here. Okay, so those will be our answers. So any questions there? Okay, so if there are no questions, that's the revision for today. So we've covered again questions on trigonometry and further differentials. Okay, so I don't know when your quiz is, but I just encourage you to continue studying. Okay, make sure you know how to solve all the questions in the tutorial and the tutorial sheets. Okay, the videos are there on the website. You can watch all the videos that you want. I mean, you can watch the videos on all the questions. I solved all of them. Okay, and then also I'm going to solve all these questions. This is test one. Okay, where I was getting the questions. This was test one for last semester. So I'll solve all the questions here, and you can find the video on the website in the folders for past papers. Okay, so that's it for now. Have a blessed night.